Hello students, today we'll study force and pressure, and this is lecture 3 where we will study regarding the pressure. Now this pressure we are using, as you have seen in kitchen, we are using knife or some pointed object we are using. So why this? Just to increase the pressure, right? So we can deform one object or we can reform one object using the pressure. So this pressure we will discuss here. Now the pressure is what? This is actually the force. This is actually the force. Just a minute. This is actually the force whatever you are applying per unit area. So pressure is defined as the force per unit area, okay, where F, that is the force, P, that is the pressure, A, area, okay. So pressure is defined as the force per unit area. If a force F is applied on a surface area, then pressure P is defined by F equals to P by A. Okay. And so the pressure is expressed in terms of what? The pressure can be expressed in terms of our force and area also. In terms of force and area also. So the pressure can be expressed in terms of Pascal. Okay. So this pressure P, this is the pressure, and always we are using Pascal to as a unit of the pressure. Okay. Now pressure here, whatever I have told in very first slide, that we are using some size of the object or some object, we are just reforming it just to increase the pressure. Like here you can see the nail, okay, here you can see the nail. What you have seen, this point is this is pinpointed. If you take the alpine, at that time also you can see this point is very pinpointed, right? Pinpointed. So why this we are doing? Because it is easier to push a nail into a wooden plank by its pointed end than its head, because the pressure is more. Okay. So whenever you have some pinpointed surface here, at that time it is easy to press it, or it is easy. Why? Using less amount of pressure, you can penetrate this point to a very certain depth. So here, if we want to cut the vegetables, what we will take? Or obviously some sharp knife we will take, and blunt knife will not take. Sharp knife, because in this case, here, this surface is very important, right? And it is sharp. So this surface, whenever we are applying some force here per unit area, what will be the pressure you are giving? What will be the force you are giving? That is the pressure. So here you can see that the pressure, that is force per area, here the force you have to give very small amount. That means the pressure is small amount you have to give here. Now you can see that always you are going to school or you are going to any institute with a shoulder bag which has very broad straps. Why we are using this? Just to reduce the pressure. Otherwise, if you have that strap that is very thin, at that time you can see that particular this area of your shoulder, it will just press your shoulder, and at that time you will feel very high intensity of the pressure. You will feel very high intensity of the pressure. So here in this case, you can see that the air pressure you have in this balloon. So balloon here, it becomes harder to blow the balloon, because whenever it becomes bigger and bigger, at that time you can see that the atmospheric pressure, that is also high like your air pressure. This air pressure is very high amount, and this atmospheric pressure, that is also very high at that time. So that means this is the air pressure inside the balloon that will increase. That's why you can see that whenever I want to blow the balloon, whenever it is already blown up, at that time you can see that it is very hard to blow. Then here, suppose we have in a container water, okay, or any liquid here, and one ball you are just dipping it into it. At that time you can see that whenever you are pressing this ball, and that if it is very less weight, and it has very less weight, whenever you are pressing this ball, at that time you can see that very you will try to move upward, and this is, that means you can feel that someone is applying the force against you. So this is the thrust. This is the thrust. And in a block, always we are applying the pressure that is perpendicular to all the surfaces. Okay. So in this surface, this is one surface, and this surface, or the force, whatever the pressure you are applying, that is perpendicular. In this surface, the top surface, you can see that all the pressure that applied perpendicular. Here also, bottom also, in the left side also, you can see that there will be some applied force will be very high. Now, this pressure, that can be also defined as a thrust and area. Now, what is thrust? Again, I am just discussing just to memorize this thing. Suppose I have a container here, and here I have water. I have water, and here you can see that, some ball you are trying to dip it. That means you are applying the force against this. So what you are doing, actually, you are trying to dip it, and that means it will move towards the gravitational force. So if I'm applying some force, or I'm not applying any force, I'm just throwing one ball into the pond, at that time what you can see, the ball that will move downward, or it will just penetrate inside the water level due to the gravitational force. That means the gravitational force that attracts the ball. So another force that will be acted on it, but it is in the opposite direction of the gravitational force, that is called the thrust. That is called the thrust. So 1 Pascal, that equals to 1 Newton per 1 meter square. So the thrust is the pressure into area. Thrust is the pressure into area. So this pressure which produces a thrust on the object is the reason some objects float in the water. You can see that if this is the container and you have water here, here you can see that some block, and if you want to dip this one, sometimes it will be just at the bottom of this water level, or it may be floating. So all these things that happens due to the thrust. So this is the reason why so many objects may float on the water level, or so many objects it can be go just bottom of the water level. So Pascal's law, here you can see this one. In this image, there is a piston here, piston A, and this one is piston B, this arrangement. So here you can see that we have one liquid here or water here. The column is filled with the water. Now, if I am giving some force in this direction. That means I'm just piston A is pressed. At that time, the new position of this, suppose it is here. New position, suppose it is here. So at that time, you can see that this piston B, it will rise upward. It will rise upward. The new position of the piston B, that will be like this. That will be like this. Okay, that will be like this. So piston B will rise. So here we are using the Pascal's law to the fluid pressure. So what is the Pascal's law? We'll study here. The external static pressure applied on a confined liquid is distributed or transmitted evenly throughout the liquid in all directions. The external static pressure applied on a confined liquid is distributed or transmitted evenly throughout the liquid in all directions. So the static pressure acts at right angles to any surface in contact. So like we have already discussed, suppose you have one block here and the pressure we are applying that is perpendicular to this stone. That means this is the right angle. This is the right angle. Okay, or 90 degree. Or 90 degree. Fine. This pressure that is also will be applicable on the right angle. So according to Pascal's law, the external static pressure applied on a confined liquid is distributed or transmitted evenly throughout the liquid in all directions. So this statement is very, very important and you have to remember the Pascal's law. Here what happened, you have seen that, I'm trying to draw the picture again. So here, there was a piston here. And there was a piston here. So this was B and this was A. So if I am applying pressure here, at that time you can see that the piston will move downward and this piston will move upward. Why? Because the total volume, whatever you have inside this structure, that should be same. So if I am just going to reduce the area in this case, that means the area in this portion that should be increased. That's why you can see that the piston B that rises upward, right? So that means whatever the external pressure I am applying, I have applied the pressure to the piston A. So whatever the pressure, external pressure I have applied in a confined liquid, this is a confined liquid because in this liquid you have closed the mouth with piston A and you have closed this mouth with piston B. So it is distributed and transmitted evenly throughout the liquid. That's why piston B rises whenever piston A here, it will be pressed downward. Okay, it will be pressed downward. Sorry. So here, Pascal's law is over. That means Pascal's found the pressure at any point of the Pascal's also found that the pressure at any point of the static fluid that will be same across whole area of the fluid. And this is Pascal's law or Pascal's principle or principle of transmission of fluid pressure. Just a minute. This is called known as Pascal's principle or principle of transmission of fluid pressure. In 1653, Pascal's law was stated by French mathematician Blaise Pascal. Okay, so according to his name, it has been named that it is the Pascal's principle, and it has been said that whatever the pressure you are applying at any point of the static fluid means you have a confined fluid, right? So this pressure will be same across all planes passing through that point in that fluid. Okay. So according to Pascal's law, whatever the force you are applying, that equals to pressure and area. So here, just a minute, where F, that is the force applied, P is the pressure, and A is the area. Okay, and this is the cross-sectional area. Now, using Pascal's law, we'll try to solve these questions. Let me change the color of the pen. Solution. Here, according to Pascal's law, F equals to PA. Now P, that is pressure, force, F, A is the cross-sectional area. So P has been given here 2000 Pascal. And area, that is 0.1 meter square. So force equals to P into A. So I can write down that is 200 Newton. Okay. So answer is, what force is applied? 200 Newton force is applied. Okay. Next, there are 3 figures here, and brick. Here we have, let me start from this portion. Weight 2 kgf, dimension 20 centimeter into 10 centimeter into 5 centimeter. Now what I have to find out? The pressure exerted by the brick in each case. So this is the case 1 or A, B, and case C. For case A. Okay. So here weight of brick, that equals to 2 kgf, right? And area of base, that equals to how much for the case A? That is 20 centimeter into 10 centimeter. So that will be our 200 centimeter square. Now we know that pressure, that equals to area. So pressure P, 2 kgf, 200 centimeter square, that will be 0.01 kgf per centimeter square. Fine. kgf, that is also CGS unit, that's why I'm not changing it. Next, case B. Here again, area of base, that equals to area of top, that equals to 5 centimeter into 10 centimeter. that becomes 50 centimeter square. So the pressure force by area that equals to 2 kgf divided by 50 centimeter square. So it will be 0.04 kgf divided by centimeter square. See, area of base, area of top 5 centimeter into 20 centimeter, that equals to 100 centimeter square. Just a minute. This will be 20. So pressure, this is the force by area. So 2 kgf divided by 100 centimeter square. So pressure that equal to 0.02. This is point kgf by centimeter square. Next, how much thrust will be required to exert a pressure of 20,000 Pascal on an area of 1 centimeter square? Here, pressure P, that is the 20,000 Pascal, and area, that is 1 centimeter square. Let it be convert into meter. So force, that is 20,000 10 to the power minus 4, that is 2 Newton. Okay. So this much thrust will be required to exert. So here you can write down the answer. 2 Newton thrust will be required to exert. Next question, the moment of a force of 25 Newton about a point is 2.5 Newton meter. Find the perpendicular distance of force from the point. Let's solve this one. So force applied, that is 25 Newton. Now the perpendicular distance from the point of rotation, let be D. So moment of force, that equals to force into D. So 2.5, 25 into D. From this we can evaluate 25 divided by 2.5, that is 10 centimeter. Okay. So here the perpendicular distance of force from that point is 10 centimeters. Fine. Now the thrust, I have told, if you want to dip any object, then you can feel that any object in the water surface, you can feel that some force is acting against yourself. That is the thrust. So if gravitational force is acting in towards this direction, that means thrust will be upward. If you have gone to swimming, at that time you feel that your weight has been reduced because the net force that you are feeling. So here, always the fluid applies an upward force on a body submerged in it, and this fluid pressure or this force, that is called the thrust. Now this force is in the opposite direction to the force of gravity. So if you have this container, you have water inside this one ball you just throw inside this, you can see that the gravitational force will be in this direction, but the thrust will be in this direction. So it reduces the total force acting downwards due to gravity on the object. That's why whenever a swimmer swims, at that time he feels or she feels that some light weight is there. So what is thrust? That means from these two slides we have studied that thrust is the force that acting normally on the surface, and the SI unit of the thrust is Newton. So thrust is the force which moves an aircraft through the air. Thrust is used to overcome the drag of an airplane, to overcome the weight of a rocket. So these are the several applications of the thrust. Now the electrostatic charge. The force of attraction or repulsion, already we have told that we have source of attraction or repulsion in between two types of the charge. Now what are the two types? One is called positive charge, another is negative charge. One is, just a minute. One is positive charge, another is negative charge. Positive charge is denoted by plus, negative charge is denoted by minus, right? And these two are electrostatic charge, right? Electric charge. So the force of attraction or repulsion experienced by a charged body from another charged body in the same vicinity is known as electrostatic force. If you have one positive charge here, another negative charge here, they will attract each other. If you are keeping two positive charges side by side, you can see that they will repel each other and they will try to move away from their own other position. Similar thing for the negative charge. Now the nuclear forces. This is very, very important because this is the strongest force. Whatever the forces you have studied, that this is the strongest force. So the nuclear force that acts between all the particles in the nucleus. That is between neutrons and between two protons, between a neutron and proton, right? And this is the attractive force. It is the force that keeps the nucleus intact by overcoming the enormous repulsive force between positive protons. So always you can see that whenever you are just going through chemistry, at that time you can see that suppose this is the nucleus and we cannot affect this nucleus, whatever the electrons you have in the outer shell, you can share these electrons or you can use these electrons. So in one atom, there are two parts. One is called nucleus One is called nucleus, and it consists of proton and neutron, and they are tightly bonded. And another thing, that is the shells. In every shells you have some electrons, right? So here, and subshells also there. So I'm not going very much in detail here in this lecture, but you should remember one thing: in one atom, it may be hydrogen atom, it may be oxygen atom, it may be oxygen atom, hydrogen atom, it may be hydrogen atom. You can see that you have two parts. One is the nucleus, another is the shells. And you have in the nucleus proton and neutron, and other thing, that is the electron, right? So what are the thing? That is proton, neutron, and electron, right? Now the distribution of pressure. A few things I have discussed earlier. Here I will discuss elaborately what happens. Now you can see that, suppose you have this dull knife. Can you drag anyone? Can you cut anything using this dull knife? No. Large area is here. If you want to do any work with this knife, you have to give a very high amount of force. It might be a poor part of your work will be done. But here you can see that this is very pinpointed. This is pinpointed, right? This is pinpointed. And if I am applying where a small area is here, so if I am applying the force, you can see that it will penetrate in this, it will penetrate this object. So the sharp knives always we are using, right? Now, porters, they place a round cloth on their heads to increase the surface area and reduce the pressure. Or you can see sometimes in the railway stations, you are just calling coolie, right? So coolie, you just come and take my luggages. So at that times also you can see they are keeping one round cloth on their heads. Then they are placing your heavy suitcase or heavy luggage, right? So this they are doing it to reduce the pressure. Okay, so this is the distribution of the pressure, and this distribution of pressure always we are using in our daily life. Now fluid pressure, here this is the pressure at a point within a fluid arising due to the weight of the fluid. The pressure in fluid can be calculated using the following relationship. I will say what is the relationship. Now fluid pressure we are using to measure the pressure. Also sometimes I think from fluid pressure you have in your mind that the pressure machine also, the not digital one, the pressure machine that the most of the doctors they are using, the fluid mercury, the liquid mercury that you have in a you have in this, and after that you can see that the mercury will move upward, and the doctor will say that yes, the pressure will be 120/80 or whatever, right? So this fluid pressure we are using also, that we'll discuss here. Now the fluid pressure, this is the P plus rho GH, where P is the pressure at the reference point, and P fluid is the pressure at a point in a fluid. Rho is the density of the fluid. G is the acceleration due to gravity. H is the height from the reference point. So here P fluid, that equals to P plus rho P fluid, that equals to P plus rho GH, right? Here H has been shown. Now this P0, this is the initial pressure, or this is the P. Now here rho, that is the density, whatever you have some liquid here. So the density of the liquid, that is the rho. G is the gravitational force, and H is the height of the liquid, height of the liquid. Now again we know that rho is the m by v. So if you know the volume of the fluid and mass of the fluid, you can find out what will be the fluid pressure. Okay, and P0, that is the atmospheric pressure. And always you know that if you are keeping one fluid anywhere, at that time you have some atmospheric pressure, until unless you are not keeping it in a vacuum chamber. Thank you.